Hi students, we are looking at the first chapter of electrical circuit theory, okay, for diploma students, diploma triple E students, okay. Right, this is where we stopped in the last session. There are only three problems left, okay. Capacitors of 3 microfarad, 6 microfarad, 12 microfarad are connected in series across 400 volt supply. Determine the potential difference across each capacitor. Okay. So this is the situation here. Three capacitors are connected in parallel across a 400 volt supply. Okay, you need to find the capacitance of each capacitor. Okay, since capacitors are connected in series, the total voltage V is nothing but V1 plus V2 plus V3, where V1 is voltage across capacitor 1, capacitor 2, capacitor 3. Name these capacitors as C1, C2, C3, C1. Okay. So this is C1. This is going to be C2, and this is C3. Okay. So what is charge? Since capacitors are connected in series, the charge is equal. Okay. So C1 V1 equal to C2 V2 equal to C3 V3. Okay, C1 V1, C2 V2, C3 V3 is the total charge. What is the total capacitance? Total capacitance C equivalent, or 1 by C equivalent, C equivalent equal to 1 by C1 plus 1 by C2 plus 1 by C3. Okay, so 1 by 3 plus 1 by 6 plus 1 by 12. Okay, add them up. 1 by 3 plus 1 by 6 plus 1 by 12. What is LCM? LCM is 12. Okay, 3 4s are 12 plus 6 2s are 12 plus 1 12 1 12s are 12. Okay, so 7 by 12 is 1 by C equivalent. Okay, then what is C equivalent? C equivalent is going to be 12 by 7 microfarad. Okay, so what is Q then? Q is nothing but CV. Q equal to C equivalent into V, or V is the total voltage, supply voltage. So 12 by 7 into 400 volts. Okay, microcoulomb. Okay, this is the thing. Like I mentioned earlier, what I mentioned, Q equal to, the charge is same for each element in the series connected capacitors. So Q equal to C. Oh no, sorry. C1 V1 equal to C2 V2 equal to C3 V3 equal to how much? Equal to 12 by 7 into 400. Okay, uh, this is in microcoulomb. Don't forget that. C1 is 3 microfarad. Okay, what about V1 then? V1 is nothing but divided by 3 microfarad, right? So 1600 by 7 Micro will cancel out. This is volts. That is V1. What about V2? V2 by C2. 12 by 6. 2 by 7. 2 means 800 by 7. 800 by 7 volts. What about V3? V3 Q is 12 by 7 into 400 divided by 12. 12 will cancel out. So this will be 400 by 7. Okay. Add them up. This is 12 plus 16, 2800 by 7 is 400 volts. Okay. So these are the voltage drop across three capacitors. Okay. Let's see the 13th problem. Three resistors of resistance are connected in series and then parallel. Find the equivalent resistance for each case. Also calculate the power dissipated in each case. When they are connected in series, what is the equivalent resistance? R equivalent in series. You have to mention the case, right? In series, R equivalent, that is equivalent resistance is 10 plus 15 plus 25 equal to 50 ohms. Yes, 50 ohms. uh, 10 plus 15 plus, this is not 25, 20, so 45 ohms, that is in series. Okay. Also calculate the power dissipated in each case. In series only, power dissipated will be power dissipated equal to V square by R, right? V square upon R equivalent. The total power dissipated is V square upon R equivalent. So 225 upon R equivalent is 45. Okay. 45 5 ja, 5 5 ja 25, 5 4 ja 20, 45 5 ja. So this is 5 watt. Okay, this is the total power dissipated. Okay. Now in parallel we need to find, right? Okay, we'll draw a line to separate these thing and that thing. Oh, let's draw a line straight. Okay, let's separate this one from that problem. In parallel, in parallel, what is that? R equivalent. So 1 by R equivalent equal to 1 by upon R1 plus 1 upon R2 plus 1 upon R3. Okay. So what is 1 by R1, 1 by R2, 1 by R3? 1 by 10 plus 1 by 15 plus 1 by 20. What about LCM? If you ask me about LCM, it will be 5 2 ja, 5 3 ja, 5 4 ja. 5 2 ja, 5 3 ja, 5 4 ja. Okay. 23 ja, 60 is the LCM. Okay. 60. Then this is 10 6 ja, 15 4 ja, 23 ja. 13 6 4 10, 10 plus 3 13, 13 by 60, 13 by 60 is 1 by R equivalent. Okay. What about R equivalent then? R equivalent is the equivalent resistance, nothing but 60 by 13 ohms. Okay. Now you need to find the calculate the power dissipated in each case. The total power dissipated, okay, same formula, V square upon R equivalent, okay, V square is 225, R equivalent is 60 here, okay, there it is 13, 13, 13, okay, uh, mm-hmm, yeah, mm-hmm. It will go by 15, 15, 15 is 225, is that not correct? Yes, 15, 15 is 225, so 15 into 13 divided by 4, okay, what is 15 into 13 then? Oh, 15 into 10 plus 3 equal to 150 plus 45, how much? 195, okay, 195, so 195 upon 4 watts, okay, okay. Last problem, let's see. Two incandescent bulbs of 100 watt and 60 watt and rated voltage of 110 volts are supplied by a source of 110 volts DC. Determine the current drawn from the source when the lamps are connected in parallel and when the lamps are connected in series. Okay, not a difficult problem. I am looking for the space to solve the problem. 100 watt, 60 watt, 110 volts. Okay, 100 watt, 60 watt. Let me 100 watt, 60 watt. Two bulbs are there, L1, L2. What is the voltage? 110 volts. 110 volts DC. Determine the 110 volts DC. Okay. Now let's find R1. Sorry. R1 is nothing but resistance of the lamp 1, V square upon P. V square upon P1. P1 is 100, V square is 110 into 110 upon 100, 121, 11, 11 is 121, right? So 121, what are these? Ohms, okay. That is resistance of the lamp 1, resistance of the lamp 2, R2, V square upon P2. P2 is 60 watt. 3, 0, 0 will cancel out. So 1210 divided by 6 ohms. Okay. Oh, it can be still divided by 2, divided with 2. 605 by 3. Okay. That's it. That is R1, R2. Now what you need to find, A by A bit is A bit. Find the equivalent resistance. Oh, sorry. Determine the current drawn from the source when the lamps are connected in parallel and the lamps are connected in series. Okay, when the lamps are connected in parallel, A bit, that is when the lamps are connected in parallel, that we need to lamps are connected connect parallel. Okay, so when the lamps are connected in parallel, what is the equivalent resistance? R equivalent, R equivalent 1 by R equivalent equal to 1 by R1, 1 by R2, or otherwise R equivalent equal to R1 into R2 divided by R1 plus R2. Okay, how much it will be? 121 into 605 by 3, 5 by 3. Okay, whole divided by 121 plus 605 by 3. Okay, okay, right, equal to what? uh, mm-hmm, 121 into 605 divided by 121 into 3, how much? 363 plus 605, 363 plus 605, that is 121 into 605 divided by, what is the total? 538 968 968, 15 14 plus 9, it will go by 2, but not possible that from here I can say it is not possible. Okay, whatever it may be the value, what we want is current, right? Current flowing through the circuit I equal to V upon R equivalent. Okay, what is V? 110, 110 into 110 into 968 divided by 121 into 605. Okay, okay, that is the thing, that is the thing. 88, 88 plus 9, 88 plus 8. Okay, this will go by 9, 11. Okay, see 110, this also will go by 11. Okay, now let me write it in this way. Well, let's drop the 11 thing first. Okay, so equal to what? 968 only will no, 968 into 10, so 9680. Sorry again. This is 10, 11 10, 11 8 88. Okay, 11 8 88, 8, 11 8 11 88 968, right? So 88 divided by 2 11s 121, so this becomes 605. Okay, 11 5s of 55, 11 5s of 55. Okay, that means this becomes 80 divided by 11 5s of 55, 11 5s of 55. Okay, one more 11 got cancelled out. Okay, Again with the 5 you can cancel this one out. 5 1 ja 5, 5 6 ja 30 divided by 11. So 16 by 11 ampere is the current. Okay, right. Lamps are connected in parallel. Now the lamps are connected in series. That is what I am saying. Okay, in a different language. So what is R equivalent when they are connected in series? R equivalent is nothing but R1 plus R2, nothing but 121 plus 605 by 3. Uh-huh. Mm-hmm. 121. So 121 3 is 3 63 plus 605, that is 968, right? 968 by 3. Okay, 968 divided by 3 ohms. Fair enough, fair enough, fair enough. Okay, again current, in this case current flowing through the circuit in this case, when the lamps are connected in parallel, this is total current. Total current that we need to indicate, right? Okay, here only one current is there, right? Either you call it as total current. Okay, voltage is 110. Let's substitute. R equivalent is into 3. Here it will be 968. 968. Okay, so how it is going to change? 30 upon 11 8 88, 11 8 88. So 15 upon 44 ampere. So this is the total current. Okay, you got the point. He just asked only current when the lamps are connected in parallel. Yes, only current drawn from the source. Oh, right. So the total current only they asked. These two are sufficient enough. Okay, this is where we will stop the lesson here, and we will continue with the next chapter in the next session. Okay, right. Nandri, vanakkam. Are you tired of dental problems? Then listen to this. Stop brushing your teeth using plastic brush and chemical paste. Use nature's gifted neem stick for brushing your teeth and stay healthy.